Hello friends, welcome to my channel. Today we are going to design a H-shaped microstrip antenna for 5G millimeter wave communication systems. But before we go further in the design, don't forget to subscribe because I will be uploading some related work. Antennas for several applications, so that might be helpful for you maybe during your research or if you have an assignment that you want to solve using HFS. So let us start. Make sure you are at the desktop option for you to select and open the HFS files. Right, so this is the window that is going to appear as you usually know. So we can start by enlarging the coordinate system, what I usually like to do. All right, so as you know, we always have three different layers for a microstrip antenna. The first one is the ground plane that you are going to design here, and just try to change the name into a ground plane. All right, or just write a ground. If you want, you can change the color into this one or choose whatever color you want it to be. Right, so you can also change the property of the ground plane. In this case, we are going to choose a copper because we want our antenna in the ground to be a conductor. Right, so you can see the copper material here. Then you click OK, and here you have selected the copper. Then you need to position your antenna at the right position. Here I usually start at 0 at the origin. Let me give it LG as the length of the substrate, the ground plane. Give it 5 millimeter, and the width of the ground plane, give it 4 millimeter. And we have the height. It has to have a certain height, which is a standard value of 0.035 millimeter or just 35 micrometer if you are using micrometer as the unit. Alright, you can fit it. So this is basically your ground plane. So the next layer, as we know, is the substrate that you are going to draw. Just change the property like you did for the... Okay, this time is going to be, we are going to choose a Rogers substrate. Alright, and okay, so yeah, if you want, you can change the color or leave it like that. Or the transparency, you can set it to 0.5. 0.5, which is 50% of transparency. And now you can give it to the right dimensions. The position is going to be the same as the one for the ground plane. So 0 and 0. Here you can give it LG as the length of the ground plane, and WG and HP. All right, so after you've done this, you need to, you can see your box is right there. The heights need to be different. In this case, it's going to be HS, which is the height of the dielectric material. In this case, we are taking 1.575 millimeter. Just click OK, then you will see your substrate right there. Okay, so if you look at it here, I think we need to change this to HP. It need to start right on the top of the ground plane. That's why you need to start at that height. You can also change the name as substrate. Right, and here you go. Now we need to start to bring our patch. Remember, we are designing a H-shaped microstrip antenna, so you can name this one as your patch. And the patch is a copper, is a conductor. You can also choose the same color as the ground plane, or you choose the color that you would like. So the patch need to be at HP plus HS, which is right on the top. then we have, yeah, it starts at a certain value here. In this case we are having B, all right, and here we have A, and yeah, we have so looking at those values, they have been already optimized before I started realizing the videos. So you need to know that before you start your design, you should make sure that you have good values for your design. For here, B is just 0.3 millimeter and A is 0.5 millimeter. Yeah, that's it. So you can see it's going to start at the right place. Okay, so in terms of x-axis, that is LP that we are going to use here, and LP is 3.5 millimeter in this case, and we have WP, which is just 3 millimeter. All right, and HP, I mean, it's supposed to be HP here. Right, so this is your patch that you have already designed. So the next step of your design, you need to cut some slots on the H shape, I mean on the rectangular shape here. So just draw a box again, name it slot 1, and give it a copper. Okay, apply. You can also change its color, even though that's not very much important, but you can change the color to make it uniform, to make it look like, yeah, right. So you can change the dimensions of the slot. Where is it going to start? In this case we have it's going to start at B, and it's going to be on the y-axis is supposed to start at A, and on this one suppose HP plus HS. Right, so you can see it right there at the top. Okay, so now we need to assign the dimensions. Let's say L1 here is 1 millimeter, and here we have W1, which is also 1 millimeter, and PP, which is the height of the patch, I mean the copper. Right, so you can see this is your your first slot. So on the y-axis here you can see it starts at B on the x-axis, while on the y-axis it's going to be WJ divided by 2 minus W1 divided by 2. Alright, so you'll see it right here. So this is your first slot. So you can just copy it like this. Okay, use the shortcut, select it and copy and paste. You can see we have slot 2. So what we have to do here is just on the y-axis that we are going to change. On the y-axis we will have B plus LP minus L1. Right, so you can see it has been copied here. So now what we should do, we need to subtract from the 2 slot from the patch. Just hold the control button and slot 1, slot 2, and then select start by the patch, slot 1, slot 2, and come to modeler, and then choose your Boolean option. Then you can see subtract. So you don't have to change anything here, just press OK. You can see it has been subtracted from the patch. Alright, so what you can do here, you need to bring your feed is going to be the box as we usually do it. So you can name it feed Alright, and you can change it into copper, and you can change the color to make them uniform. Even if you don't change the color, once you unite them, they are going to be the same. So this is just to show you guys how you can do it. So for the feed line, we have the initial position of the feed line is B plus LP, okay, LP minus L1. So this way is going to start. On the y-axis we have WJ divided by 2 minus WF, which is the width of the feed line, and then we choose here on the z-axis HFSS. As you know, here we have 0.02 as the width of the feed line. Okay, and now on the length of the feed line is LF, which is in this case 2.2 millimeter, and the width of the feed line, and finally we have HP that we have here. So you can see your feed line right here. So without wasting time, you are trying to unite the two. You just do the same. You click on the patch and you hold the control button, click on the feed, and then go to modeler, choose your Boolean option and unite the two. You can see they have been united. So the next thing is to feed your antenna. So we can choose this one, try to feed it. But before you feed it like that, you need to change, you can delete it and change the orientation of the axis. So you can now bring your circular shape, which is going to be your port, and yeah, you can leave the color the way it is, and then try to change the dimensions. Here it needs to start at the starting position is just LG, and on the y-axis we are going to start at WJ divided by 2 minus WF divided by 2. Just need to remove this minus sign. Alright, so and then lastly we have HP plus HS. Now we have on the y-axis and on the z-axis we have the minus, as we did for, we are going to HP plus HS. It's going to be the same. So you can see your antenna. Now you need to assign your antenna terminal, ports, lumped element, choose the ground, and here you go. Now you need to assign the frequencies setup advanced. You can always choose the 28 in this case in my design, because I'm using the millimeter wave frequencies. So you have your sweep, you can leave it like that, or you can just change the interpolation into fast frequency, and then you try to simulate your design. Everything is okay, so you just start running the simulation. But before, you need to save your design, project 3 in this case, and okay, now the simulation has completed. So we are going to try to see the results. You just come to result, right click on it, and you can see rectangular plot, and then you just click new report to see the plot. You can close it and can bring some markers by right clicking on the workspace, and yeah, you have designed an antenna that resonates at 34.23 gigahertz. So thank you for watching. Don't forget to subscribe, and see you next time.